Okay, so the first and the simplest system is to solve by graphing. If you are going to solve, and this is probably the least likely that you would use, okay, but there are questions that, like you see here, that show up on the SAT where they give you the graph and you interpret that. So if you are going to solve by graphing, what's going to happen is you're going to take the graphs of whatever you're given. They'll generally be linear equations. So you'll graph two lines, and then wherever they intersect, that's going to be the solution point. Okay, and so if you look at this, problem right here, I want you just to really quickly see if you can answer which of the following has the same solution. And when you are solving by graphing, you're simply going to find the intersection. What's the coordinates at this intersection? The x coordinate is 6, the y coordinate is 2, and so that's what you're looking for. X is 6, y is 2. That's going to be your equation. Now, they put this in a slightly different format. Here, what they're saying is it's not just saying the x value is 2 and the y value, or the x value is 6, the y value is 2. Here, it's giving you a new system, and it's asking you to look at the equation y or x equals 6 would be this vertical line right here. The equation y equals 2 would be this horizontal line, and that would be the intersection. Okay, but really, it kind of comes down to you're just saying that the x value is 6, the y value is 2 for a question like this. Like I said, solving by graphing, because it's a lot more error-prone, so it's not used as often as these other two methods, right, that we're going to talk through. So, and both of these methods, you can use either one. Okay? Substitution is usually used if one of your equations has a single variable x or y in it with no coefficients, nothing being multiplied in front. And if you are going to solve by substitution, what you're going to look to do is solve one of your equations for one variable. Again, you're normally going to pick the variable that doesn't have a coefficient or has a leading coefficient of 1. Look to isolate that if you can. So in a problem like this, and I'll show you, you can use both methods or either method for almost all of these questions. But here, this would be conducive to solving by substitution. Because what you could do is you could solve one of these equations for an unknown. So looking here, we want to solve for y. So that means that we need to leave everything in terms of y's. So if I take this first equation right here and I solve for x, and I do that by subtracting y from both sides, that would be the first step. We isolate one of the equations with a single variable. Next, you're going to substitute that in. In the other equation. So here, if we take this value for x, we're going to come down, and in this second equation, we're going to replace the given x with what we are just determining here, that x is equivalent to 7 minus y. So if we substitute that in, 7 minus y for that x, plus the 7y is equal to 25, leave everything else the same, you're then going to solve that equation. So I'm going to refer to it as solve the equation from step number 2. So solve number 2, we're now going to solve this equation for whatever the variable that remains. And so here we get 7 minus y plus 7y is equal to 25. You don't really need that step since there's nothing to get rid of in the parentheses. If we combine our terms, we have a negative y and a positive 7y gives us 6y. I'm going to subtract the 7 from both sides, and that gives 18. Divide by 6, and we get y is equal to 3. Now, that's the solution we were looking for. If they were asking you to find the remaining variable, that would be a fourth step. Again, in that first problem, we don't need the fourth step. We've solved our problem. But in the last step, what you would do is you do what's called back substitute. The solution that you got in step 3 to find the other variable. So what that would mean in this problem would be if we come to any of the equations that we have set up to solve for x, so this would probably be the best one, and we could back substitute, take that x is equal to 7 minus y, but instead of y, replace that 3 in, and that would give us x is 4. So if they were asking for the whole solution point, it would be an x of 4 and a y of 3. Right? However, this problem was just asking you to find the y. All right, I want you to see if you can use that method to solve this question right below. Through this one, I'm going to show you both a mathematical way to solve this because that's just a good, it's a good opportunity to review that. However, before I even get to that, let me talk through the SAT specific strategy. Okay? And that is, as I mentioned before, and I will continue to mention, the very first thing I would do on any SAT math question is scan the answer choices. And what do you notice about these answer choices? They're all really similar, right? And they're either, like the answers are either both +1, both -1, or one of each, one positive, one negative. Right? And so the easiest way to approach this problem is just start plugging in those answer choices, right? One of those has to be correct. Okay? So the fact that we look at this first equation up here, x plus y equals 0, that tells us that the x and the y have to be what? The same value or opposite values? They're opposite. So right away, we can eliminate those two answer choices. It has to be one of the other two. Okay? And so if you just plug those into the second equation and test it, that's the easiest way to solve this problem. So let's say I plug in this one. Okay? So 9 times a -1 minus 6 times a +1, does that equal 15? -9 minus 6? No. And so by process of elimination, I have my answer, but I can also substitute that in. Plug in a 1 for x, plug in a -1 for the y. Does that equal 15? 9 minus a -6 plus 6? Yes. And so that would be your easiest way and the sort of the most efficient way to solve this problem. All right, let's actually go through, though, and talk through this if we were solving by substituting. Okay, so if we were going to solve this by substituting, what we would do is we would solve one of the equations for a single variable. And you can solve either x or y. It doesn't matter which one you choose. Let's say we take this first equation here and we solve for x. X is equal to subtract y from both sides. So there is our value for x. Once we get to that, we move to the second step, which is to substitute -y in for the x of the other equation. So 9 times this -y minus 6y is equal to 15. So we take the second equation, substitute that in, and solve, giving us -9y minus 6y equals 15. Combine these, we get -15y is equal to 15, divide by a -15. We get y is equal to -1. And when we plug that back into this equation right here, we get x is equal to a -1, which tells us x is 1. So there's our answer, 1, -1. It confirms what we got. The other way, again, when you're solving the SAT, you want to work quickly. So if you have a strategy that works faster for you, that's the strategy you should be using. Right, so that's substitution. You can solve any one equation for a single variable. Now, there will be times like here when you do that, you wind up with fractions, and so that might not be the easiest way to approach. So if we look at this next example here, if you're going to try to solve for x or solve for y, you might get some fractions in there. So the other way is called linear combination or the method of elimination. And the way that you would solve this is you're going to manipulate one or both of your equations. Often it can just be one. Okay? In order to cancel variables using some kind of a direct combination of terms. Okay? So here's what that looks like. Okay, so linear combination kind of looks like this. You need to make the coefficient of one variable or one equation the opposite of the coefficient of the other. So when we look at these two equations, we want to try to find one of the variables that we can make the coefficient opposite the other one. Well, if I take the lower of the two, so let's say we take this, the coefficient, let's say we're looking to cancel the, we want to solve for x's. I know it's going to be a little bit more roundabout way here, but if we want to cancel the x's here, and what we can do is we can multiply the entire lower equation by what number so that the coefficients of x's would be opposites. The current one is 2x. We need it to be the opposite of the other equation, 6x. So how would we take 2, make it the opposite of 6? Multiply by a -3, right? So the -3 is going to create opposite coefficients. And so if we take this, we still have our 6x plus 7y equals -6. That's our original first equation. And if we distribute this -3, multiply every term by a -3, we get -6x minus 6y is equal to +12. And then you're going to just combine this. The linear combination step is to go straight down column of like terms. The x's cancel. We get +1y is equal to +6. And so there is our y value. Be careful that you don't choose that as your answer because it's asking us to solve for the x. And once you find one of them, you can back substitute once again to find the other variable. And so we can use any equation that we have here, and you generally will want to choose whatever the simplest equation is, the one with the smallest numbers or easiest to use form. So this is the equation I'm going to plug that y of 6 into. So I get 2 times x plus 2 times y, which was 6, is equal to -4. And when I back substitute this to solve, I add or multiply 2 and 6, I get 12. And here, if I subtract 12 from both sides, I get 2x is equal to -16. And finally divide by 2, I get my x value to be -8, and that would be my solution. Okay, so this is called linear combination, or the method of elimination. Okay, once again, you can do this with any of them. We could have taken the equation on the left, and we could have multiplied everything in the top equation by a -1. That would have canceled our x's. Or we could have multiplied everything in the top equation by a -7. That would have canceled all our y's, and so on. All right, so I want you to try this last example here. You can use any method. And so the easiest thing here would be to use substitution, right? Because one of our equations just has one variable, so we can solve for x here. If we took 2x is equal to 12, and we divide by 2, we get x is equal to 6. Once we solve for one of the equations for one variable, we can then plug that in. So we get -5 times our x value, which was 6, plus y is equal to -21, and we solve. If we add 30 to both sides, here we get our y value is equal to 9. And so when we take our x plus y, we have 6 plus 9 gives us 15, and that would be our solution here. All right, so this is solving systems of equations by substituting or linear combination. Okay, we'll talk later about solving, there are other types of systems that exist on the SAT that are a little bit more like this last form, where it asks you not to solve for an individual variable or an ordered pair, but it gives you a combination of them. There's another method that we'll talk about later and bring this up again when we talk about that. All right, the final slide has to do with what happens when you're solving a system and either everything cancels or it creates a system that is inconsistent. Okay. First is, what if you get to the form where everything cancels on both sides? You get the exact same number, okay, and it could be any number, okay, but all of the variables cancel and you have the same constant on each side of your equation. If that's the case, that means you're going to have infinitely many solutions. Okay, that means that it has the same slope and the same y-intercept. Okay, both of those conditions apply, and if that's the case, you have infinitely many solutions. Okay, any number, or there's any number of combinations for that. Now, if you have variables that cancel and you get a statement that is inconsistent, so you get something like this, where 0 is equal to 5, that doesn't work. That's not a true statement. If you have -5 is equal to 1, again, not a true statement. So if all of the variables cancel out and the constants on each side are different, then you're going to have something that's referred to as no solutions. Okay, on this one, they are going to have the same slope, but they're going to have different y-intercepts. And really what that means is these are parallel lines, and up here, these are the same line. These are just two equations that represent the same line. So that's the no solutions and the infinitely many solutions. Okay, we already did a problem like this previously, so I'll kind of skip that one. Okay, but I want you to, if you take a look at these problems here, okay, if we look at this first one, when you look just at this equation, and it's written in slope-intercept form, right? You have a slope of -8. You have a y-intercept for your top equation of 1, for your bottom equation, -4. So if you recognize that, you can see that these have the same slope, same slope, but different y-intercepts. So if that's the case, if you recognize that just by looking at the rules, then you know that these are going to have no solutions. There'll be no solution for this. If you don't see that rule, then what you would do is use one of the methods that we looked at in the previous slide, and you're going to look to combine them. So here I've already solved one of the equations for one unknown, so I'm going to plug that in. If I take this expression right here, 8x, or -8x plus 1, I'm going to substitute that in for this y, set that equal to -8x minus 4, and if I add 8x to both sides, I get the relationship that 1 is equal to -4. Is that a true statement? No. It's inconsistent in that regard, so we know that it's a no solution, even if we're trying to solve that by hand. All right, try the next one over here. Take that system, see if you can find what would be the value of C in order for this to have no solution. Okay, for no solution, what do we know about the slopes? They have to be the same. And so what would be the value of C that gives you a slope equivalent to the top equation? 5/4. Nice and easy. Again, if you understand the concept, okay, there's no calculations necessary. It's just an understanding. All right, I want you to try to answer this question. And again, here, be careful with how it's worded. Okay, but see if you can solve that problem. So this question is based on the relationship that when you're looking at a system, there's one of three things that's going to happen. Okay? And I'm going to talk about it visually and graphically. So one possibility is what we see right here, where you can have this line right here, and then if you have another line that is just the same exact line, but a different way to say it, this is an example of the infinitely many solutions, right? So that one would be infinitely many, same slope, same y-intercept. Now, if you had that exact thing and you had a line here where the slope is exactly the same, but the y-intercept now is down here instead of up above, instead of in this area right here. And now they have the same slope, but they're different y-intercepts, so this would be no solution. These lines are parallel. They're never going to intersect each other. Okay? And if you compare that to this final example here, if you took a line and you moved it here, now you have this one intersection. So this is a solution, or this is a system that will have one solution point. Okay, so you're either going to have one solution right here. You're going to have an infinite number of solutions right here. Infinity is the number of solutions here. Or you're going to have no solution, which is what we see in this case. Here, we went the parallel line. Okay, so it's not asking you to find your x value or your y value for this. It's asking you just to find, is there one solution, no solution, or infinite number of solutions? So by recognizing the instructions, you can eliminate these two. The only possibilities are 0, 1, or infinitely many. So when you look at this, if you did solve this, which I assume you guys solved by substituting, you took this expression for y and plugged it in here, giving you 9x is equal to x plus 12. Subtract x from both sides, you get 8x is equal to 12. Divide by 8, you get x is equal to 4 goes into 12 3 times, 4 goes into 8 twice. So notice that's similar to this. This is our x value. If you plug that in and solve, this would be most likely our y value, but it's not asking for that. It's just asking, do you have a solution? Yes, and there's only one. And so be careful on that question. It's not asking you to solve it. It's just asking you, is there one solution, no solution, or infinitely many solutions? All right, the final question you should be able to do without having to really calculate, just by looking at what you have. See if you can answer this final question here. Which of these systems has no solution? As you can see here, these are all pulled from the practice digital SAT. It looks like they have a relatively strong emphasis on the no solution of understanding that you're going to have same slope, different y-intercepts. Okay, so which of those answers would be correct there? Okay, which of these have the same slope but different y-intercepts? Very last one, right? The slope of 12 is the same, the y-intercepts are different, and so your solution is going to be option D or whatever that last choice is.